The next thing that we're going to look at is Introduction to Systems of Equations in a little more detail. We're going to talk about the different scenarios that can happen for systems of linear equations. In order to complete this section or to understand this section, you want to be able to rewrite an equation in slope-intercept form. Upon completing this presentation, you will be able to determine the number of solutions to a system of equations by looking at the components of the equation. You will understand the difference between a consistent system and an inconsistent system. You will understand the difference between independent equations and dependent equations. So let's talk about what we have here. Just like we saw when we were looking at equations in one variable, we said that there were three possible outcomes. The first one was that you could have one solution, and that is the first outcome that you can have when we talk about systems of linear equations. Graphically, in order to have one solution, you have two lines that intersect at a single point. In order for two lines to intersect at a single point, then the equations have to have different slopes. If the slopes are different, then the lines are not parallel. And if the lines are not parallel, then they must intersect. So one of the things to note is when we were in the previous chapter, we talked about intersecting at a right angle. And in this chapter, we're just going to generalize it to intersect, period. So if you have two lines that have different slopes, doesn't matter what they are, they will always intersect at a single point. The main thing is that the slopes have to be different. If the slopes are the same, then it is not going to have one solution. So our second possibility that we saw when we looked at equations in one variable was there was no solution. And that is also a possibility when we talk about systems of equations. Graphically, in order to have no point of intersection, that means that our lines are parallel. What does it mean to be parallel? It means they never intersect. In order to have parallel lines in terms of our equations, these are lines that have the same slope. We've talked about that in the previous chapter. This time we're going to be a little bit more specific. They have to have different y-intercepts. We want to make sure that they start at different locations. So for instance, if we have lines that have the same slope, but they start at different locations, then they are never going to intersect. And that's about as good as I can do right there. So hopefully you can see that. Again, same slope, different y-intercepts, no solution. Our final possibility that we saw when we looked at equations in one variable, linear equations in one variable, was that you could have an infinite number of solutions. Systems of linear equations, you have the same thing. Remember that each line has an infinite number of points on it. And in order to have an infinite number of solutions, this means that the lines lie on top of each other. They are the same line. Equations, what will our equations look like? The equations have the same slope and the same y-intercepts, meaning they are the same equation. Now, one thing to note is though there is an infinite number of solutions, the solutions are not all real numbers since the solutions are now ordered pairs. This next part you don't necessarily need to know for this course, but just as kind of a little factoid for when you get to your future math classes. To write the solution, you will take one of the equations and put it in the following form. X comma y, you have a vertical bar, and then whatever your equation is. The x plus 3y equals 7, this is just a general equation. And what this statement says is all points x, y that satisfy the equation x plus 3y equals 7, or whatever your equation is. Again, note, you will not be required to write this notation in this class, but it may come up in future math classes. Okay, so let's get into some vocabulary now. We have two ways that we're going to talk about systems of equations. The first one is we can talk about the system. A system can be consistent or inconsistent. A consistent system is a system of equations that has at least one solution. So our possibilities for consistent is systems of equations that intersect at a single point or lie on top of each other. Note, consistent sounds positive, which means we have a solution. An inconsistent system is a system that has no solution. Systems of equations that result in parallel lines are inconsistent. So if they have same slope, different y-intercepts, you will have an inconsistent system. Inconsistent sounds negative, so no solution. Our second set of definitions that we have is independent and dependent equations. Independent equations are equations that are independent of each other. So what does that mean? What does it mean to be an independent person? It means that you do your own thing. So independent equations have different equations. Systems of equations that intersect at a single point or result in parallel lines are independent. If you are an independent person, you do your own thing regardless of what other people are doing. In terms of our parallel lines, one of them may be below the x-axis, and the other one may be above the x-axis. They are in different locations at the same time. Dependent equations. These are equations such that the behavior of one depends on the other. They have the same equation, or they lie on top of each other. If a point is a solution to one equation, depends on whether it is a solution to the other equation. If you are a dependent person, you would probably answer yes to the question. If everyone else jumped off a cliff, you would do it too. Another example, if you think about an infant is dependent on you. You have to take it everywhere. So note, a system of equations can never be inconsistent and dependent. But systems of equations, you can have all other possibilities of combinations of these four definitions. So we're going to go ahead and look at some examples and determine if our solution of equations is consistent or inconsistent. We want to know if the equations are independent or dependent, and we also want to know what is the number of solutions. So in order to do this, our first step is to rewrite each equation in slope-intercept form. For example A, we already have that we have this in slope-intercept form. We have already solved for y. So the only thing we need to do is look at slopes and y-intercepts. The first thing that I notice here is that my slopes are the same. So that means that these lines are either parallel or the same line. My slopes are the same and my y-intercepts are different, which means that they are going to be parallel. They start at different locations and they move in the same direction. They will never intersect. So that answers our first question. How many solutions do we have? This system has no solution, since they are strictly parallel. There is no number that you can plug in for x and get the same y value. So now we want to know, is it independent or dependent? Well, they're doing different things. They may be walking on opposite sides of the street and going the same direction, but they are still on opposite sides of the street. And so these are going to be independent equations. And since we have no solution, this is also going to be an inconsistent system. And we're done. All right, let's move on to example B. Example B, we have 2x plus y equals 3, 4x plus 2y equals 6. Again, the first thing that I want to do is rewrite these in slope-intercept form so that I can compare my two equations. Make sure that when you do this, you do simplify slopes and you simplify y-intercepts. You need to simplify everything as much as possible. So if we start with our first equation, my first equation, in order to rewrite this in slope-intercept form, I want to solve for y, which means I need to subtract 2x from both sides. So we get y equals negative 2x plus 3. And we're done with our first equation. For my second equation, I want to also solve for y. So my first step is to get rid of the x term. Since I want to get y by itself, I want to move everything else to the other side. We get 2y equals negative 4x plus 6. And then I can divide each term by 2. And we get y equals negative 2x plus 3. So what do we notice about these two equations? Well, the first thing that I notice is that my slopes are the same. So that means that we either have parallel lines or the same line. The other thing that I notice is my y-intercepts are also the same. So what does that mean? We have the same line, and if you look at these equations, they are the same equation. So that means that these two lines lie on top of each other. So we have an infinite number of solutions. And for this class, that's all you need to that's all you need to write. Infinite number of solutions. The other thing that we have is this consistent or inconsistent? Well, we do have a solution. We have an infinite number, so we do have at least one, which means that this is a consistent system. And our equations are dependent. Since they are the same, they are going to be at the same location at the same time, all of the points are going to be the same, and so they are dependent. And we're done with example B. Finally, let's look at example C. Example C, we have a system of equations, 2x plus 3y equals 6, and 2x plus y equals -2. Our first step again is going to be to write in slope-intercept form. So in order to do that, for our first equation, we have 2x plus 3y equals 6. I want to solve for y. I'm going to start by subtracting 2x from both sides. My 2x's cancel on the left, leaving me with 3y equals -2x plus 6. From there, I want to divide both sides by 3 and divide all terms by 3. Thus, we get -2/3 x plus 2. Remember to simplify whatever you can simplify. For our second equation, we want to do the same thing. So we have 2x plus y equals -2. In order to solve for y, I want to subtract 2x from both sides. And we get y equals -2x minus 2. And we're done for that one. So now the first thing we want to look at is our slope again. So on this problem, note that our slopes are different. And since our slopes are different, that means that these lines are not going to be parallel. They're not going to be the same. We don't even have to worry about the y-intercepts on this. We can go ahead and state exactly what this is. Since they are not parallel and they are not the same, they have one solution. These lines intersect. The other thing that we have is they are going to be a consistent system, since they are going to intersect at a single point, and they are also independent. One of them is a fairly shallow line. The other one is a steep line. So they are doing different things at the same time. So those are some examples of our 3 different cases that we can look at. Now, this is not the only way to show that we have one solution, no solution, infinite number of solutions. As we talk about solving equations, we will run into these same cases again, and we will talk about what are we going to see algebraically in terms of solving systems of equations. So when will we see this again? Irregardless of the number of equations in a system, if they are linear, the result will always be one of the 3 options mentioned here. In future math classes, you will look at systems of 3 equations, 4 equations, etc. Depending on how far you go in math, you may be required to take linear algebra, which is an entire class devoted to exploring systems of linear equations. Once you have finished this presentation, please answer the following questions as part of your notes. How confident are you with the material presented here? What from this section needs to be explained further? And how much more practice do you need to be comfortable with the topic?